So here's page 11 in your packet. Okay, so I'm going to do a couple with you right at the beginning, and then I'd like you to pause the lecture. So CS2, again, all of these you'll notice have two different nonmetals bonded together. So right away we can identify it's a covalent compound. If it's a covalent compound, we use prefixes. There's one carbon, so we don't use the prefix mono. So it's carbon, and two sulfurs. The prefix is di, and sulfur becomes sulfide, carbon disulfide. SO2, sulfur dioxide. Okay. To do formula writing, same thing. Once you identify that there's prefixes, I know that I don't have to worry about charges. I can just simply use the prefix to get the subscripts. So bismuth is Bi. Trioxide tells me there's three oxides, three oxygens, BiO3. Dinitrogen monoxide. Di tells me there's two, so two nitrogen. Mono is one. Dinitrogen monoxide. I don't have to worry about any charges. The prefixes tell me the subscripts, and that's it. I'm done. It's very, very simple. So why don't you pause the lecture now and go ahead and do the rest of these, and then restart the lecture. And when you restart it, I will have all these answers popped up so you can do a quick look at all of them. All right, so I've got my final answers here, and hopefully you've done some of your extra practice. Now can check over them. SO3 is sulfur trioxide. CO is carbon monoxide. SbCl3 is antimony trichloride. And again, if you're not sure on the name of the element, you could always look it up. Sb is antimony. As is arsenic, so diarsenic trisulfide. Again, if there's more than one for the first element, we do have to use a prefix. CO2 is carbon dioxide. As2Br5 is diarsenic pentabromide. Bismuth tribromide, and carbon tetrachloride. And again, if you were to spell these wrong, it's not a big deal. As long as you're close phonetically, I would give you credit for it. The big key is to have the right prefix in front of the substance. And then starting at C, dinitrogen penoxide is N2O5. Oxygen difluoride is OF2. Silicon tetrabromide is SiBr4. Dinitrogen trioxide is N2O3. Silicon dioxide is SiO2. Sulfur tetrachloride, SCl4. Diarsenic trioxide, As2O3. And phosphorus pentachloride, PCl5. And that's how we do covalent compounds. Right? Now for acids, all right, again, to name them, the first thing we have to do is identify PO4 polyatomic, SO3 polyatomic, Cl2 polyatomic, Se not polyatomic. If there is oxygen in it, remember, if there's oxygen in the formula, okay, then we are not going to use hydro. Okay, but H2Se doesn't have oxygen, so we will. So right away, this will be hydro blank ic acid. So all I got to do now is add the root word of the second element. Se is the element is selenium. So I'll take off the ending, and I have hydroselenic acid. Hydroselenic acid. Okay, something like HBr would be hydrobromic acid. H2S, S is sulfur, sulfuric acid. Okay, so if it doesn't have oxygen, hydroblank acid. Okay, now if it's polyatomic, if the polyatomic ion ends in an 8, we're going to change it to an ic. If it ends in ite, it's going to become an us. So PO4 is phosphate. So it ends in an 8, so now I'm going to end in ic. Phosphoric acid. Now some people forget to put the or back on because it was phosphorus. For some reason when we have an 8, that all drops off and it's just phosphate. If you were to say phosphic acid, I would not mark that wrong, but it's phosphoric acid. SO3 is sulfite. Sulfite becomes sulfurous. Again, the comes back in. If you were to say sulfurous acid, I would not mark you wrong. And CO2 is chlorite. Ite becomes us, so this is chlorous acid. Okay. Writing formulas of acids. Chloric acid. We don't see hydro, so I know it's got to contain H and an O and something else. And that something else has to be chlorine because we see the prefix chlorate. Chloric, if I go backwards, came from chlorate. Chlorate is ClO3. It has a -1 charge. So that tells me I just need one hydrogen. The charge on the negative ion tells me how many hydrogens I need. Okay. Sulfuric. Sulfuric comes from sulfate. Sulfate is SO4 negative 2. There's a 2 on there, which tells me I need 2 hydrogens out in front. Okay. If you want to pause the lecture now and try to do C and D, please do. When we restart it, I'll go through them. Hydro, I see hydro, so right away I know that it's just H and one other element, in this case fluorine. The charge on fluoride is negative 1, so I only need one H, so it's just simply HF. If the charge on the negative ion is negative 1, we just need one H. If it's something other than negative 1, negative 2, or negative 3, we need to add 2 or 3 hydrogens respectively. Nitrous came from nitrite. Nitrite is NO2 with a negative 1. So it tells me all I need is an H. Erase that charge, and I am done. Now again, for the test, you only have to worry about writing formulas. So this is what you'd be tested on. You are not going to be tested on naming. And that's because when we get into reactions, you have to take the names of chemical compounds and write their formulas. Okay? Because then you will be able to balance chemical equations and then go on to the next step, which is called stoichiometry. So the homework. All right, today's lecture is going to go over how we name covalent compounds and acids. And here's a page that I have that goes over the key points. You might want to snapshot this, take a picture of it, so you have this to work off of. First of all, at the top, if the top part here is for covalent compounds. So you have a covalent compound, again, 2 nonmetals bonded together, or multiple nonmetals bonded together. Well, how we'll name it, and usually the formula is always going to be of some type of variety of X to some subscript, Y to some subscript. Okay, so it is contained 2 elements. The first element, we never use the prefix mono. Okay, so if there's only one of them, we never use mono. We just name what that first element is, and the name of it matches its element name. Great example of that is obviously a CO2. We don't say monocarbon dioxide. We say carbon dioxide. Okay, so the first element, if you only have one of them, you are only going to use the prefix mono if there's more than one. So carbon dioxide. The second element always ends in "ide," so oxygen becomes oxide, just like for ionic compounds. And we always use a prefix, even if there's one of them. So CO2 is called carbon dioxide. CO is called carbon monoxide. So the second element, we always add a prefix to it. Okay? And that's how we name covalent compounds. When we are looking at acids, first of all, if something is an acid, it will always begin with an H in this class. If the formula begins with an H, it's immediately an acid. There are 2 types of acids. The first type is called a binary acid. A binary acid is hydrogen plus one other element type. Okay? Now, that could be HX, it could be H2X, it could be H3X. But there's hydrogen, some number of hydrogen, with another element. Okay? To name binary acids, it's very simple. We use the same naming system. Hydroblank-ic acid. Whatever the name, root word of the name of the element X is, for example, if it's chlorine, HCl, we name HCl as hydrochloric acid. The root word of chlorine, chlor, we throw in here, and we have hydrochloric acid. Okay, because it begins with H, we always end in the word acid. So we tell the reader that is an acid, hydrochloric acid. Whatever, if we change the nonmetal to something else, we just change the word of that element. If it's sulfur, it's sulfic, and so on and so forth. Okay? Oxyacids is hydrogen, again begins with H, but now it contains a polyatomic ion. XO is some type of polyatomic ion. First of all, we never, ever, ever use hydro with an oxyacid. So if it begins with H and it contains a O somewhere in the formula, we are not going to use the word hydro. Simply put, whatever the name of the polyatomic ion is, we change the ending of it and we add acid. So for example, if it ends in an 8, if the polyatomic ion ends in an 8 becomes ic. So nitrate acid actually is nitric acid. Ate becomes ic. If it ends in an ite, it changes to an us. So nitrite acid actually is nitrous acid. Okay? And that's how we simply name acids. All right? Formulas of acids, whatever the charge on the anion is. So if the anion has got a charge of -2, hydrogen has always got a charge of +1. So ideally, it's very simple. The charge on the negative ion is how many hydrogens begin the formula. So if the charge is -2, we're going to have 2 hydrogens to begin the formula. If it's 3, we're going to begin with 3. If it's a 1, then it's just 1 hydrogen to begin the formula. Same thing for oxyacids. Nitrate is NO3 -1, which means I only need 1 hydrogen to balance it because hydrogen's got a +1 charge. So the formula of nitric acid is HNO3. And that's how we get formula of acids. For covalent compounds, the prefixes tell you the subscript, and it's very, very simple. So let's do some practice problems. For tomorrow is for you to go ahead and do these problems here on page 12, and you're all going to do formula writing. And again, I have thrown in a couple ionic ones that keep you honest. So if you see no prefixes, it's ionic. So there we have charges, and the charges, you should cross-drop them to get the formula. If you see prefixes, it's a covalent compound, and they're pretty simple to do. The prefixes tell you the ratio. And if it's an acid, you should see the word acid at the end of the word, which means we know it begins with H, and now we have to make sure to know how to write formulas of acids. All right, so go ahead and give this a try. When we are in class for the next week or so, we will do a little bit of practice on this in class, just so that you get some practice leading into it. But this is the last part of this unit, and now we are through covalent compounds. So there will be a lab on Lewis structures using the molecular model kit for those that are in class. And otherwise, we'll have this homework this week. There's a quiz on molecular geometries, the stuff from last week. And then next week, we'll be reviewing and getting ready for our first test of quarter 3. Again, thanks for listening.